So for now, what we've done is we've sketched cotangents and tangents. Now what we're going to do is graph what I would probably say a little bit easier would be the cosecant and secant graphs. Keep in mind that they both have a period of 2 pi, but they do have some undefined values. So to graph your cosecant and secant, you have to take the reciprocals of your y-coordinates of y equals sine of x and y equals cosine of x. So if you look down here at the cosecant, the reciprocals, basically if you take the reciprocal of 1, you're just going to have a 1. But if you were to plot a sine curve in here, so go down through here, come back up, and look like that. And if you notice, if you just take your, basically what I do, we're not going to sketch a ton of these, is if you just take your sine graph and if you just basically draw a parabola facing up there and a parabola facing down at whatever your amplitude is, and then draw in your asymptotes, then you will be in good shape. So we're not going to get too fancy with these and plot all kinds of points and stuff like that, but then you'd have another one over here. Keep in mind that a couple things you need to keep in mind though is for a cosecant, in the first you have 3 asymptotes, and in between the first 2 your graph is opening up if your amplitude is positive, and in the second, in between second and third, it's opening down. If you were to reflect that by putting a negative in front, then the green part would be facing down in the first set, or in between the first, I can't even talk, in between the first asymptotes, and then the green part would be facing up in the second part. The secant's a little more confusing because you have your secant, but it is undefined at these points, at pi over 2 and at 3 pi over 2. So when you look at the asymptotes for your secant, here at pi over 2 you have an asymptote, and then you have another one at 3 pi over 2. So what I have you do is one interval would actually, it looks a little bit like the cosecant, but it's shifted. So when we actually graph one interval of your cosine, or sorry, of your secant, if you think about your cosine, it goes down like this, comes back up, not over there, and comes around like that. Well, what you're going to graph is you're going to have one little, what looks like a parabola facing down, and then you're going to have a half parabola over here, half parabola over there. So you have to keep in mind we're still going from 0 to 2 pi. It just looks a little confusing. It basically looks like your secant looks basically like your cosecant, only shifted to the left by a pi over 2. But in order to get one period of this, you need to go from 0 to 2 pi, and you're going to have, well, it looks like 2 arms and a couple legs down here, I guess, for a stick man. So let's look at example 4. Here we're going to graph a cosecant function, and our amplitude is going to end up being a 1/2. So we're only going to need to go up to a 1/2. I'm going to go down to a negative 1/2. You have a b value here, and your b value is this 2. So that's going to tell us what our appropriate interval is on. So this is a b, 2 pi over b is what that should be. So you're going to have 0 to 2 pi over b. So if we go 0 to 2 pi over 2, this is going to be our appropriate interval. It's going to end up being from 0 to pi. So we're actually going to shrink our value here. Now that means our total distance of our period is pi. So we're going to start at 0, and we're going to go out to pi. So if we go, let's say pi over 2, pi over 4, pi over 2, 3 pi over 4, and pi, this is where our other asymptote's going to be. So there's your asymptote there. And then you also have one in the middle. And since if you think about your cosine or your sine, what I do is I like to do a little, it's opening up this way, parabola, it's opening up there, and then you go down to a negative 1/2 because that's your your amplitude, going down, and then you would want to go through and erase some of your sine graph that you put in here. So get rid of those little blue dots, maybe. So small I can't even erase them. And then what you have is a cosecant with an amplitude of 1/2 and a period that was shrunk down to a pi. And it was not shifted, so goody goody gumdrops. All right, there's example 4. Another cosecant here, and let's throw in, we're going to throw a little shift in here. Notice that we're still going to have the same amplitude of 1/2. So your amplitude is still 1/2. And then what we're going to have to do is we're going to factor this 2 out. So we're going to say we have a 1/2 cosecant 2 on the outside, x plus, remember if you take a 2 out of here, you're actually multiplying this denominator by 2. So you're going to be pi over 4. And so this basically looks exactly like the last equation, except we have a shift. So we're still going to have the period. There's going to be a distance of 0 to 2 pi over b, or 2 pi over 2, which is still going to be from 0 to pi, but this is actually going to be shifted. So we're going to shift to the left a pi over 4. So when we shift to the left a pi over 4, our new interval is going to be from negative pi over 4, because you got to take 0 minus pi over 4, and pi minus a pi over 4 is a 3 pi over 4. So here are your intervals. And then we can actually go ahead and start plotting this. So if we're going to go back to a negative pi over 4, we're going to have pi over 4 here, pi over 2, and 3 pi over 4. Because it has been shrunken. So we are going to put our asymptotes in at negative pi over 4. We're going to put our end asymptote out here at 3 pi over 4. And you're going to put one in the middle. And if our amplitude is 1/2, if we go up a half right here and down a half, then what we're going to have is our sine function is going to go up through here, down to negative half, and back up. So we're going to start at a half. Draw your parabola looking shape going up. Go down to negative half. Draw your parabola shape looking down. And basically this is the exact same graph as what we did for A, except we just shifted it to the left.